Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. Which AWS services or features provide high availability and low latency by enabling failover across different AWS regions? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, the emphasis is on ensuring high availability and low latency, which are critical factors for maintaining application performance and uptime, especially under failure scenarios. The key operational requirement here is failover across different AWS regions, which narrows our focus significantly. Not all AWS services are designed to operate seamlessly across regions. We're specifically looking for those that leverage a global network footprint to route user traffic intelligently and automatically to the next available endpoint if a failure occurs in one region. The ability to distribute traffic globally and react to outages is at the core of services that truly support multi-region failover strategies. Option B, Network Load Balancer. Network Load Balancer, NLB, operates at the connection level, layer 4, and is designed for ultra-low latency within a single region. It distributes traffic across targets in one or more availability zones in a single region, but it does not support cross-region failover. Incorrect, because NLB is region-specific and does not offer cross-region failover. Option C, Amazon S3 Transfer Acceleration. S3 transfer acceleration is intended to speed up uploads to S3 buckets by routing data through Amazon CloudFront Edge locations. While it reduces latency for data uploads from distributed locations, it is not involved in failover or high availability for application endpoints. Incorrect, because S3 transfer acceleration improves upload speed but doesn't support multi-region failover. Option E, Application Load Balancer. Application Load Balancer, ALB, operates at the application layer, layer 7, and balances traffic within a single region across multiple availability zones. While it ensures high availability within a region, it does not natively support failover across regions. Incorrect, because ALB provides regional high availability but lacks cross-region failover capabilities. Option A, Amazon Route 53. Amazon Route 53 is a highly available and scalable domain name system (DNS) web service. It supports routing policies such as failover routing, which can automatically direct traffic to healthy resources in another region if one region becomes unavailable. It is also integrated with health checks to monitor endpoints, making it a reliable component for cross-region failover. Correct, because Route 53 supports high availability and failover routing across AWS regions. Option D, AWS Global Accelerator. AWS Global Accelerator is specifically designed to improve the availability and performance of global applications. It uses the AWS Global Network to direct traffic to optimal endpoints and supports automatic failover across multiple AWS regions, ensuring low latency access even if one region fails. This is one of the most suitable services for multi-region high availability. Correct, because Global Accelerator routes traffic across regions and enables fast, automatic failover. A company often does not use all of its current Amazon EC2 capacity to run stateless workloads. The company wants to optimize its EC2 costs. Which EC2 instance type will meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. This scenario highlights a familiar and financially impactful situation: underutilized EC2 capacity and the presence of stateless workloads. The mention of stateless is particularly important. Stateless applications can handle interruptions or instance terminations without affecting the overall system stability or data integrity, which makes them ideal candidates for more cost-effective and flexible compute models. Also, the phrase optimize EC2 costs signals that the company is looking for a pricing strategy or instance model that reduces expenses without requiring full-time guaranteed compute capacity. So, We're seeking an EC2 purchasing option that's cost-efficient and well-suited for workloads that can tolerate interruptions. Option B, dedicated instances. Dedicated instances run on hardware that is dedicated to a single customer. This provides isolation at the physical level, but comes with a significantly higher cost compared to shared tenancy. Since the goal is to optimize costs, especially for stateless workloads, this option doesn't align well with the requirement. Incorrect, because dedicated instances offer isolation, but are not cost-efficient for stateless, intermittent workloads. Option C, reserved instances. Reserved instances require a long-term commitment, typically 1 or 3 years, and are best suited for steady-state, predictable workloads. They offer substantial discounts compared to on-demand pricing, but don't provide the flexibility needed for workloads that often don't utilize full capacity. Also, paying for unused reserved capacity would further defeat the purpose of cost optimization. Incorrect, because reserved instances reduce cost for steady usage, but not for variable, underutilized workloads. Option D, on-demand instances. On-demand instances provide the flexibility to launch and terminate instances at any time without upfront commitments. However, they are charged at the highest per second rate, making them the least cost-efficient option when utilization is inconsistent and when stateless workloads can handle interruptions. Incorrect, because on-demand pricing is flexible, but the most expensive for sporadic usage patterns. Option A, spot instances. Spot instances allow you to take advantage of unused EC2 capacity at discounts of up to 90% off the on-demand price. Since these instances can be interrupted by AWS with short notice, they are ideal for stateless, fault-tolerant workloads that don't require continuous uptime. The companies need to optimize costs, and their tolerance, for instance interruption, makes spot instances the perfect fit for this scenario. Correct, because spot instances are highly cost-effective and ideal for stateless workloads that tolerate interruption. A company hosts a large amount of data in AWS. The company wants to identify if any of the data should be considered sensitive. Which AWS service will meet the requirement? Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, we begin with a company that hosts a large amount of data in AWS. A clue that this use case involves data storage services like Amazon S3. The core objective is to identify whether any of the data is sensitive, pointing to a need for automated data classification, pattern recognition, or PII detection. This isn't about access permissions or infrastructure compliance. It's about understanding the content of the data. So we need an AWS service purpose-built for scanning and classifying stored information to determine sensitivity levels. Option A, Amazon Inspector. Amazon Inspector is an automated security assessment service, but it focuses on identifying vulnerabilities within Amazon EC2 instances, container images, and Lambda functions, not on analyzing data stored in S3 or classifying its sensitivity. Incorrect, because Amazon Inspector is for infrastructure vulnerability scanning, not data sensitivity classification. Option C, AWS Identity and Access Management. IAM is used to define who can access what, offering fine-grained control over AWS resources. However, IAM does not evaluate the contents of the data or determine whether it is sensitive. It only enforces access controls and permissions. Incorrect, because IAM controls access but cannot detect or classify sensitive data. Option D, Amazon CloudWatch. Amazon CloudWatch is a monitoring and observability service for AWS resources and applications. While powerful for collecting metrics, logs, and setting alarms, it doesn't have the ability to scan or classify stored data. Incorrect, because CloudWatch monitors performance but doesn't inspect data content. Option B, Amazon Macie. Amazon Macie is specifically designed to discover, classify, and protect sensitive data stored in Amazon S3. It uses machine learning and pattern matching to detect personally identifiable information, PII, financial records, credentials, and other sensitive data types. Macie provides a dashboard, alerts, and integration with other services for remediation. In this scenario, where the company wants to identify sensitive data, Macie directly satisfies the requirement. Correct, because Amazon Macie uses machine learning to scan and classify sensitive data, making it the right choice. Which AWS service can a company use to visually design and build serverless applications? Let us identify and interpret key phrases in the question that will help with answering it. In this scenario, a company is looking for an AWS service that allows them to visually design and build serverless applications. The keyword visually is crucial. It implies a user interface or drag and drop environment rather than code first or CLI-based development. The second important phrase is serverless applications, indicating components like AWS Lambda, Amazon API Gateway, Amazon Event Bridge, and other event-driven services. The ideal solution will allow users to architect these components interactively and intuitively, likely through a GUI-based tool. Option A, AWS Lambda. AWS Lambda is a compute service that runs code in response to events and automatically manages the underlying infrastructure. While it is a key component of serverless architectures, it does not provide a visual design interface. Developers must write and deploy code using the CLI, SDKs, or IAC tools such as AWS SAM or CDK. Incorrect, because Lambda runs serverless code but doesn't offer a visual application design experience. Option B, AWS Batch. AWS Batch is a fully managed service for running batch computing workloads, typically used for compute-intensive jobs like simulations or large-scale data processing. It is not related to serverless application development, nor does it support visual design capabilities. Incorrect, because AWS Batch is used for batch processing, not visual serverless app development. Option D, AWS App Runner. AWS App Runner simplifies running web applications and APIs from source code or container images, abstracting infrastructure management. However, it is geared toward containerized applications, not serverless workflows, and lacks a visual design tool. Incorrect, because App Runner deploys web apps from code or containers, but doesn't support visual serverless workflows. Option C, AWS Application Composer. AWS Application Composer is designed specifically to visually design and build serverless applications. It allows users to drag and drop AWS services like Lambda, step functions, SQS, and more onto a canvas. The tool then automatically generates AWS CloudFormation or AWS SAM templates to provision the infrastructure. This makes it ideal for architects and developers who want to map out and iterate on serverless workflows with minimal code to start. Correct, because AWS Application Composer provides a visual, canvas-based tool to build and iterate on serverless architectures with ease. Which Amazon EC2 instance pricing model can provide discounts of up to 90%? Let us identify and interpret key phrases in the question that will help with answering it. This question targets the Amazon EC2 instance pricing model that can offer the deepest cost savings, up to 90%. The key phrase here is up to 90%, which points to highly variable, steeply discounted pricing, typically used for non-critical, fault-tolerant, and interruptible workloads. It's also important to distinguish between models that offer predictable long-term savings versus those designed for cost efficiency under flexible conditions. Option A, reserved instances. Reserved instances, RIs, offer a significant discount, up to 72% compared to on-demand pricing, but they require a 1 or 3 year commitment. These are best suited for steady-state usage where workloads are predictable. However, the discount does not reach the 90% mark that the question refers to. Incorrect, because RIs offer solid long-term savings, but not as high as 90%. Option B, on-demand. On-demand instances provide maximum flexibility by letting users pay for compute capacity by the hour or second without any long-term commitment. While this pricing model is convenient, it comes at the highest per unit cost and offers no discounts. Incorrect, because on-demand gives flexibility but does not offer discounts, certainly not up to 90%. Option C, dedicated hosts. Dedicated hosts are physical servers dedicated for your use, allowing you to use your existing per-socket or per-core software licenses. These are designed for compliance and licensing needs rather than cost savings. In fact, dedicated hosts are among the most expensive EC2 options and certainly do not offer steep discounts. Incorrect, because dedicated hosts focus on compliance, not cost optimization. Option D, spot instances. Spot instances let you purchase unused EC2 capacity at massive discounts, up to 90% off on-demand pricing. These instances are ideal for workloads that are interruptible, such as data analysis, image rendering, and CI/CD jobs. The pricing is highly dynamic and subject to availability, but no other EC2 pricing model offers this level of cost savings. Correct, because spot instances deliver the highest discount, up to 90% for flexible, fault-tolerant workloads. A company is using Amazon DynamoDB for its application database. Which tasks are the responsibility of AWS? According to the AWS Shared Responsibility Model, choose 2. Let us identify and interpret key phrases in the question that will help with answering it. In this question, the core focus is the AWS Shared Responsibility Model as it applies to Amazon DynamoDB, a fully managed NoSQL database service. The shared responsibility model clearly delineates which tasks fall under the purview of AWS and which are the customer's responsibilities. The question specifically asks about AWS's responsibilities, not the customer's. So it's crucial to identify duties related to the underlying infrastructure and platform operations. Fully managed services like DynamoDB abstract operational complexity, leaving AWS accountable for certain foundational aspects. Option A, classify data. Classifying data, determining its sensitivity, categorizing it by compliance needs, and deciding on data retention is entirely the customer's responsibility. AWS provides tools and services, but how data is tagged, labeled, and classified is up to the customer. Incorrect, because data classification is always the customer's responsibility. Option B, configure access permissions. Configuring access permissions, such as setting up IAM policies, fine-tuning table-level access control, and managing identity federation, is something customers must do. AWS offers IAM and resource-based policies, but how they are applied is up to the customer. Incorrect, because customers must configure access permissions for their services and data. Option C, manage encryption options. When using DynamoDB, AWS provides multiple encryption options, such as server-side encryption with KMS. While AWS manages the technical infrastructure for encryption options provided within DynamoDB, the customers can choose whether or not to use encryption and manage their own keys. AWS will ensure encryption is correctly applied at rest or in transit when enabled by the customer. Incorrect, because the actual selection of the security options based on the use case is the customer responsibility. Option D, provide public endpoints to store and retrieve data. DynamoDB operates through public endpoints provided and managed by AWS. These endpoints allow users to interact with the database via API calls. The configuration and reliability of these endpoints, including DNS, regional replication, and availability, are AWS responsibilities. Correct, because public endpoints are provisioned and maintained by AWS for service access. Option E, manage the infrastructure layer and the operating system. As a fully managed service, AWS handles all aspects of the underlying infrastructure: servers, storage, networking, and the OS that runs the DynamoDB engine. This includes patching, scaling, fault tolerance, and high availability. This is a fundamental part of AWS's responsibilities under the shared responsibility model. Correct, because infrastructure and OS management are core AWS responsibilities in managed services like DynamoDB. A company is migrating its workloads to the AWS cloud. The company must retain full control of patch management for the guest operating systems that host its applications. Which AWS service should the company use to meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. This question centers on a key aspect of cloud responsibility: patch management for the guest operating system, OS. The company is migrating to AWS, but wants to retain full control over how and when the guest OS is patched, which is a critical requirement for certain security or compliance-heavy applications. Therefore, we need to evaluate each option by looking at how much control the user retains over the operating system in each AWS service. Fully managed services typically abstract this control away, while infrastructure-level services leave it in the hands of the user. Option A, Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database service. It abstracts away the underlying infrastructure, including the operating system. Customers only interact with the service through APIs and are not responsible for any OS-level tasks such as patching. Incorrect, because DynamoDB does not give access to the underlying guest OS, so patch management is handled entirely by AWS. Option C, AWS Lambda. AWS Lambda is a serverless compute service where customers upload code, and AWS manages all underlying resources, including the OS, runtime, and patching. Users cannot access or patch the operating system. Incorrect because Lambda abstracts away infrastructure and OS responsibilities from the customer. Option D, Amazon RDS. Amazon RDS is a managed relational database service. While you can control some database level settings, the underlying OS is fully managed and patched by AWS. Customers do not have control over guest OS updates or patch schedules. Incorrect because RDS hides the OS from the customer and patching is handled by AWS. Option B, Amazon EC2. Amazon EC2 offers virtual servers in the cloud, giving customers full control over the guest operating system. Users can choose when and how to apply OS patches, install software, and configure settings. This is ideal for use cases that demand tight control over security and system updates. Amazon EC2 is the only option that allows the customer to retain complete control over patching and maintaining the guest OS, aligning precisely with the requirement in the question. Correct, because EC2 provides full guest OS access, making it the right choice for custom patch management. A company wants to integrate its online shopping website with social media login credentials. Which AWS service can the company use to make this integration? Let us identify and interpret key phrases in the question that will help with answering it. This question focuses on enabling a social media login integration for a company's online shopping website. The critical requirement here is the ability to authenticate users using external identity providers, IDP, like Facebook, Google, or Apple. The goal is to allow seamless sign-in experiences using familiar third-party credentials. We need to identify an AWS service that can support federated authentication, specifically for web and mobile apps, and handle identity federation with external social IDP. Option A, AWS Directory Service. AWS Directory Service is designed primarily for integrating AWS resources with Microsoft Active Directory. It's useful for managing corporate users and their access to AWS and on-premises environments. However, it's not built to support public identity providers like Google or Facebook for web or mobile application sign-ins. Incorrect, because it is not intended for consumer authentication via social logins. Option B, AWS Identity and Access Management, IAM. IAM is used to manage access and permissions for AWS resources. It controls access for AWS services and accounts, but does not offer out-of-the-box support for authenticating users via social media providers. IAM is powerful for internal AWS management, but unsuitable for external user login integration in web apps. Incorrect, because IAM handles AWS user access, not federated app logins with social media. Option D, AWS Identity Center, AWS Single Sign-On. IAM Identity Center is ideal for managing workforce access across AWS accounts and third-party applications using SAML or OIDC. It's tailored for business users needing SSO across enterprise platforms, not public consumers logging in through social platforms. Incorrect, because it is best for enterprise SSO, not consumer-facing social login features. Option C, Amazon Cognito. Amazon Cognito is purpose-built for user authentication in web and mobile apps. It supports federated identities, enabling users to sign in using social identity providers such as Google, Facebook, Amazon, and Apple. It also offers user pools, secure token handling, and integration with AWS services, making it the most fitting service for integrating social login on an online shopping website. Correct, because Amazon Cognito is specifically designed for integrating user authentication, including social media logins, with web and mobile applications, making it the best fit for this scenario. A company is storing sensitive customer data in an Amazon S3 bucket. The company wants to protect the data from accidental deletion or overwriting. Which S3 feature should the company use to meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. In this question, the key concern is protecting sensitive customer data stored in Amazon S3 against accidental deletion or overwriting. This is not a question about encryption or security from unauthorized access, but rather about preserving data integrity and enabling recovery from user or system errors. We are looking for an S3 feature that keeps prior versions or prevents permanent loss of objects due to accidental operations. Option A, S3 Lifecycle Rules. S3 Lifecycle Rules are used to automate the transition of objects to different storage classes or to schedule their expiration, deletion. While lifecycle policies help manage cost and automate data archiving or cleanup, they do not prevent accidental deletion or overwriting. In fact, they can actively delete data if not configured properly. Incorrect because it is designed for cost optimization, not protection from deletion or overwrites. Option C, S3 bucket policies. S3 bucket policies are used to define access permissions at the bucket level. They help control who can access or perform actions on objects, but they don't automatically preserve previous versions or recover data if it's accidentally deleted or overwritten. Policies help manage access, not version history or data recovery. Incorrect because it controls access, not data retention after modification or deletion. Option D, S3 server-side encryption. S3 server-side encryption is critical for data confidentiality. It ensures that data is stored securely by encrypting it at rest. However, this does nothing to prevent deletion or overwriting. Encryption is important for securing sensitive data, but it does not address accidental data loss scenarios. Incorrect because it encrypts data, but doesn't prevent it from being lost due to accidental actions. Option B, S3 versioning. S3 versioning is designed to protect data against accidental deletion or overwrites. When versioning is enabled on a bucket, every object modification results in a new version, and deleted objects can be recovered by retrieving a previous version. Even if a user deletes or overwrites a file, older versions remain accessible unless explicitly removed. This makes S3 versioning the best fit for maintaining data integrity and ensuring recoverability of sensitive customer data. Correct, because it provides full protection against accidental deletion or overwrite by keeping all object versions. A company is hosting an application in the AWS cloud. The company wants to verify that underlying AWS services and general AWS infrastructure are operating normally. Which combination of AWS services can the company use to gather the required information? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. In this question, the focus is on verifying the health and operational status of AWS services and infrastructure that support an application running in the AWS cloud. The company isn't asking about application-level monitoring or cost optimization. They're looking to understand whether AWS managed infrastructure and services are functioning normally. So we're not troubleshooting a specific instance, but rather observing the broader AWS service landscape, both publicly and account-specifically. Option B, AWS Systems Manager. AWS Systems Manager is primarily used for managing and automating operations on your AWS resources, such as EC2 instances or configuration compliance. While it offers valuable insight into your own infrastructure, it doesn't provide visibility into the operational health of AWS services themselves. Incorrect because it is focused on managing customer-owned resources, not AWS-wide service health. Option C, AWS Trusted Advisor. AWS Trusted Advisor provides real-time recommendations across areas like cost optimization, security, and fault tolerance. It's a proactive tool for improving AWS usage, but not intended to monitor or report the current health status of AWS services or the AWS infrastructure layer. Incorrect. Helps improve usage, but doesn't monitor AWS service health. Option E, AWS Service Catalog. AWS Service Catalog enables organizations to manage approved IT service offerings. It's useful for standardizing deployments, but it has no role in monitoring or reporting on AWS infrastructure health or service performance. Incorrect because it manages internal service templates, not AWS infrastructure health. Option A, AWS Personal Health Dashboard. The AWS Personal Health Dashboard delivers account-specific alerts and remediation guidance when AWS is experiencing events that may impact your resources. Unlike the public dashboard, this service focuses on how issues affect your workloads directly, making it essential for diagnosing service-impacting issues in your account. Correct because it provides personalized alerts for service disruptions affecting your resources. Option D, AWS Service Health Dashboard. The AWS Service Health Dashboard offers a public view into the current status of AWS services across all regions. It's an ideal tool to check for broader service disruptions, outages, or maintenance events. This dashboard complements the Personal Health Dashboard by offering a global perspective, regardless of your account. Correct, because it publicly displays AWS service health, region by region, for awareness of service-wide issues. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.